Welcome to this test review for writing and solving polynomials and rational functions. Now, right before I begin, one of the things I want to remind you of, a couple of reminders, is that this review needs three things. You need to make sure that you're going to do well in the exam. You have to be able to remember. Then afterwards, you have to be able to understand it. And then finally, the last solution is to apply. Now, if you can do these three steps successfully, you'll be ready for the test. Now, if you just watch the video and don't do anything, just write everything down, you're not going to be able to remember, understand, and apply. You're not really practicing the remember, understand, and applying. Really what this video does is that it gives you a guide so you could then practice independently to get these three steps done. So let's go. So what I suggest is after you write some of these solutions down, try it on your own, or you may want to pause it before you actually do one of the solutions. And then afterwards, look at your, like if you get stuck, look at the video, and then compare it to what you were doing wrong, and then retry it again. Bring out a fresh sheet of paper, new sheet of paper, and do it again. All right, let's go ahead and get started in solving on this one. With question one, they want us to use synthetic division to find the quotient and remainder. Now, in order to do that, first of all, the quotient is the part that's being divided. So like in this case, we're going to go ahead and examine that C is going to be the value of 2. So when we do 2 on this, we're going to go ahead and synthetically divide this. Now it's important to remember that one of the steps is you fill in missing powers. This one's missing x cubed. So it should be x to the 4th plus 0x cubed minus 3x squared and so on. So when I write it in here, it's going to be important for me to go ahead and actually write down the 0 in place of the x cubed. So we'll have 4, 0, negative 3, 2, and then negative 12. All right, and now let's begin our process of synthetically dividing. Remember, this is the add column, or add row, multiply row. So when I bring down the 4, automatically fits in there, we multiply by 8. Once we get the solution for 8, 2 times 8 is going to be 16. 13, 2 times 13 is 26. 28. 2 times 28 comes out being 56. And when I subtract that with 12, I get the solution of 44. So when you write down the solution for this one, you are going to go ahead and write it down like this. You're going to write down then the actual factor x minus 2. And then this is going to be 4x cubed plus 8x squared plus 13x plus 28. And what's important is that you write the remainder divided by the actual factor. And if you wanted to prove it to yourself, guarantee the solution, you could actually FOIL this back out and get back the same solution, which is right here. That's what it equals. This equals our original function, which is, we'll classify it just as f of x. All right, lovely. Let's go ahead and move on to the next one. Now, the next one, pretty much almost the same thing. So I don't think it's going to be very important for me to do the next one. So I'll give you the opportunity to try that on your own. But let's, well, let me do it. I'll go ahead and do it. I'll just kind of, it's going to be very much the similar tactic. This time we're going to use negative 2. That's our C value. And we have a couple of missing powers. So we have 1, 3, 0, negative 4, 0, 2, and negative 12. So when we do this synthetic division, and then multiply rows, negative 2, 1, negative 2, negative 2, positive 4 is 0, negative 2 times 0 is 0, 0, 0, 2, and then negative 2 times 2. Negative 2 is negative 4, so we get negative 16 at the end. And once we get this solution, we'll go ahead and write it down. Same thing. This is really x plus 2. And this is going to be x to the 5th plus x to the 4th minus 2x cubed. 0x squared, 0x plus 2 plus negative 16 over x plus 2. And that'll be the solution for that. Okay, great. All right, let's move on to solving for 3. And now I'm going to erase some things here. So I hope you have some of this stuff written down. So let me erase that, and let's move on to Question 3 says use synthetic division to determine it's a factor. Now with this one, we're just going to use synthetic division and see if we get the remainder of 0. We get a remainder of 0. So we have a factor if the remainder is 0. So if we get an R of 0 at the end, then we prove we have a factor. So let's start solving this. We'll have let's start with 1, and 1 is going to be the C value. And with this one, there is no missing powers. 1, 1, negative 10, and 8. So my add and multiply rows. 1 times 1 is 1, 2, 1 times 2 is 2, negative 8, 1 times negative 8 is negative 8, and yes, we have this remainder of 0. So one of the things we're going to write down is, hold on a second, let me just double check my equipment, make sure that I just pulled on this really hard, make sure this thing's just working correctly still. I think it is. All right. Okay, let me get back to the problem. Once we discover this, one of the things we're going to be able to do then is write down that this is a factor. Yes, it is a factor. So we proved that with the remainder of 0. Now it says right here, use a factor term to determine if x of c is a factor, and this is if it is, then we're going to write it as a quotient. So each of these we're going to synthetically divide it. So let's start with 2. So we have 2, 8, negative 5, and 5. 2 times 2 is 4. 12. 2 times 12 is 24. We have from here, and just to make sure that I did all this right, yes. We have 19. 2 times 19 is 38. Now this is not a factor, but I'm still going to write it just in factor form, but it's not a factor because their solution is 43. So if this ends up happening, then you're just writing down as x. This is going to be x minus 2. And then it's going to be 2x squared plus 12x plus 19 plus 43 over x minus 2. Just not a factor. Okay, let's move on to 5. Now in doing 5, we'll discover we have negative 3. And then we have a missing power in this one, so you have to be careful when you write these down. You discover sometimes it's best to just rewrite the polynomial before starting, because you might miss it as you're transporting it. You know what? I didn't leave enough space for that. Put negative 90. I may have to move this whole thing because actually I don't think I have enough space. Oh well, I'll just go ahead and just start solving. That's what's important. Numbers are going to go a little tiny there. Okay, my plus multiply row. 1, negative 3, negative 5, negative 15. So negative 15, positive. Oh, yes, hold on. This would have been positive. That would have been positive. So we have to make just a small correction right here. It's going to be negative 45 right here. So negative 45, we get negative 30. And then we have positive, oh, n right here. When we wrote this was 90. We have positive 90, and we get a remainder 0. So from here, this one is going to be a factor. So we're going to go ahead and write it as x plus 3. And then the solution will be x cubed minus 5x squared plus 15x minus 30. There you go. All right, so now let's move over to 6 and 7. It says list all possible solutions for the polynomial. Now, when it says the only thing they want you to do is to list, the only thing what you're solving for is coming up with using the P and Q method. Remember, this is going to be P, this is going to be Q because it's the highest power. And your steps is to get everything and list all the possible factors. Like for factors for P is going to be 1 and 5. Factors for 2 is going to be 1 and 2. And then you put a plus or minus to all of them. So we'll write down P as plus or minus 1, plus or minus 5. Write down Q as plus or minus 1, plus or minus 2. And then we'll discover that P divided by Q comes out being plus or minus 1, plus or minus 5. And what you do is you divide each one. So like what I'm doing first is I'm dividing these two. Then afterwards, you're going to do the other two divisions where you take 2 and divide it into both of these. So the other solutions we're going to discover is plus or minus 1/2 and plus or minus 5/2. Now, one thing to remember is you don't repeat solutions with factors or even when you do division. And that may be present in this one. So let's go ahead and do the same process, same idea. This is my P, this is my Q. This lists all the factors. So I'll start with 4 over here. This is going to be just 1 and 4, 2 and 2. This is going to be 9. Now, if you notice, I didn't put -9 because it really doesn't matter, just because we're going to be doing plus or minus anyway. So with P, we're going to have plus or minus 1, plus or minus 3, plus or minus 9. This is the first instance when you notice that we're not repeating a factor. With Q, plus or minus 1, plus or minus 2, and plus or minus 4. So when we do P divided by Q, my solution is going to be plus or minus 1, plus or minus, I'm going to write 3, plus or minus 9. Then I'll move on to 2, so we'll get plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. And then when we divide by 4, we'll get plus or minus 1/4, plus or minus 3/4, and lastly, my last solution is plus or minus 9/4. So there's my list of all my possible solutions for this one. All right, lovely. Let's move forward and now work on this one. Now, this one, they want you to find all real zeros of each polynomial. Use the real zeros to write the function in factor form. Now, when you do this step, the thing that I'm going to suggest you do is graph it. You're going to discover most of the solutions on there. Or you have the option of finding the P's and Q's. And once you discover the P's and Q's, like the solutions, you could put each P and Q in here and see which one produces an answer of 0. And that's one method of another method of doing it, especially if you don't have a graphing calculator. Then it's a lot easier if you just do that method, because it gives you the possibility of not having to divide everything and doing synthetic division over and over instead of just plugging it in. But since you have a calculator, let's go ahead and do it. Now, one thing I will require is that if you graph it and you get the solutions, you're going to be required to go ahead and actually synthetically divide to prove each one. So let me bring up my graphing calculator, and let me pause this for a second. And let's go ahead and graph it. So let me bring this away, and let's bring up the graph on this one. So we're going to discover what x cubed minus x squared minus 10x minus 8 looks like. Okay, so here you go. And the things that we discover is that -2 and -1 are solutions. And 4. So -2, -1, and 4. -2, -1, and 4. So let's go back to the actual problem and write down that we're going to prove that -2, -1, and 4 are actual solutions. So you can go ahead and start whichever one you want. I'll start just with order. I'll put -2. And so technically divide that. So we got 1, -1, -10, -8. Remember, this is add row, multiply row. So we get -2, -3, +6, -4, +8, and lo and behold, 0. So once you discover that, you go ahead and move on to the next one and synthetically divide the next one. You don't have to use the let me erase some things here, because it's gonna might get in our way a little bit. One of the things I love to do is just show you that you don't have to go ahead and use the next one. You go ahead and use the same one, and we're going to divide by -1 in this case. And we'll have 1 times -1 is -1, -4, +4, and lo and behold, a 0. Now, if you wanted to take the last one, you could synthetically divide that one, and then you'll prove you get a 0 too. But you could even set this. Remember, at the last stage, this is really x minus 4 equal to 0. my very last one. So if you want, you could just add 4, and this would be sufficient too. Like if you wanted to take this one right here and do a quadratic and factor it and come up with the other two factors, that's perfectly fine as well. What's important is you do some kind of proof algebraically to show me that you understand, or you're able to use the process to come up with the solutions other than just graphing. All right, so let's do the same thing with this one. Let's go ahead and discover what the solutions are at. So let me bring up my graphing calculator. Ooh, this thing's writing. Let's fix that. Okay, let's go back to, well, I don't want that. I want to be able to select. All right, let's go ahead and now graph this one. X to the fourth minus 2x cubed minus 15x squared minus 4x plus 20. Okay. And one of the things we discover is we have 2 and 1. Actually, let me do this, because I know it's throwing some of you off. I have it set up as to go steps of 0.5. Let me change this. Let me make it by steps of 1, and it's going to look a little bit more normal than what you're used to seeing. So there we go. So we got -2 and +1, +5. So now, if I notice that's only 3 solutions, if I zoom out, that means that one of these contains a multiplicity. And the one I know that's a multiplicity is going to be this one. Actually, let me, I have the power to write. Let me go ahead and tell you which one it is. The way I know is because it turns. So since it turns, that means there is going to be a multiplicity with that. These, they're not. So one of the things that I should be anticipating with the solution is this, that we are going to go ahead and discover that my zeros, my x values are going to be -2, -2. And let me bring back the graph just to refresh me. 1 and 5. 1 and 5. So these should be my zeros. So when I synthetically divide this, it should come out that I have a couple of the zeros here. So I'll start with -2. So we have 1, -2, -15, -4, and 20. And so we'll discover that this is 1. It's -2, which is 4. -8. -23 comes out being positive. Let me see if I wrote this all correctly. Okay, so this comes up being positive 56, and something's going to happen. So something did not come out as intended. So let's see, we got 1, -2, -15. Okay, in reviewing this, one of the things I discovered is that this would have been -4, which means that this makes +8, and my correction to this is right here. So you ever discover you found a zero on the graph and you're doing synthetic division and it doesn't come out, this is when you have to go back and review your work to see what is it that you might have done wrong. So then this comes out being -7. And then from there we get positive 14. And then this comes out being then positive 10, and this comes out being -20, and there's our 0. That's what I was searching for. Okay. Now afterwards, let's you have the choice to pick which one you want. If you want, even if you do -2 again, because I know there's a multiplicity there, this should produce a 0 as well. So like if we got 1 there, 1 times -2 is -2, -6, positive 12, positive 5, -10. Here's my other 0. Now you brought this down to a quadratic. If you wanted to, you could probably just go ahead and do x squared minus 6x plus 5, and then you could discover that the two factors that add up to -6 is actually x minus 1, x minus 5, which is actually these two solutions here too. So if you want to do that, you're at liberty. If not, you continue synthetically dividing it. You're going to come up with a 0 at the end. All right, lovely. Let's go ahead and move on to this one. This one wants us to find the remaining zeros for complex polynomials. Coefficients are real numbers. So if they want a degree 6, and we're given this, One of the things I know for certain, and this is where it's important to know the conjugate pair theorem. And what's so important about this theorem is the benefit of knowing that if you have a positive I, it's going to be a negative I. If you have a 2 plus I, it's going to be a 2 minus I. Remember, it's only the conjugate portion, this part that you have negatives. This is has a real solution, but 0. So we focus on the conjugate on this. So knowing that, that means that the other two missing zeros on this one is negative 3i, and the one over here, which is 2 minus 4i. That's it. That's how easy it is to solve these. But it's very important. It's very profound, this conjugate pair theorem, that guarantees us these kind of solutions, these missing zeros. So if I count, I'll have now 6 total zeros. Same thing with this one. Let's look at the solution for 11 and discover that the only thing that's missing, this is negative 3, 2i. Remember, the negative, this part, the real solution stays the same. It's just the conjugate part that it's guaranteed to have an opposite pair to it. So that's it. That's how you solve those. Let's go on to these. Now these, they want us to form a polynomial. So when we form a polynomial, this is when we must make factors and multiply the factors back to give you your solution. So like in this case, we're going to do, to make a negative 1, my factor is going to be x plus 1. To make a 2, it's going to be x minus 2. To make a, well, this is one thing that's important. There's actually only 3 zeros in the 1, 4. There's a 3 minus I here. So then this is going to be x minus 3 plus I. And we're going to also have an x minus 3 minus I. Now, we have to know that this part, most of your lives, you're used to doing. You came with a good, healthy set of skills on how to solve that. This other part right here, and actually let me change colors to it. We need to solve, you can either do it by foiling, you can still foil, do it that way. But it was easier if you used the shortcut method that was more beneficial. It was quicker. It would just say if you do x squared minus 2ax plus a squared plus b squared, then you can go ahead and solve it a lot quicker than would be foiling. And the only thing we have to discover is, remember, every imaginary number is written a plus bi, which means that a is 3, b is 1. Let's write it down in kind of like a list form. Easier to discover. So that means that if I'm doing this portion here, let's go ahead and now solve it. X squared minus 2 times 3x plus 3 squared plus 1 squared. Because I mean x squared minus 6x plus 9 plus 1. So this comes out being 10. And now my solution is real. Over here, this is the same thing as following. So we have x squared minus 2x positive x minus 2. We combine the middle terms. We get x squared minus x minus 2. Now at this stage, once we get to this part right here, this solution, we're going to go ahead and actually FOIL it all through, which means that we're going to go ahead and take this x squared and multiply it here. So it's going to be x to the 4th minus 6x cubed plus 10x squared. Now you're going to get a total of 9 terms because this is a 3 times 3. So afterwards we're going to do, let me change color so they won't start meshing together. Negative x cubed. Oh, hold on. Let me just draw the lines. This is what I'm going to do. But I'll keep black over here. So the first one will make a negative x cubed. The next one will make a positive 6x squared. And the next one will be minus 10x. So then the very last portion here, we're going to do this. These last 3 terms. So from here, let's go ahead and write down negative 2x squared minus positive 12x. See if I can move this whole thing. Oh, I gotta move it in pieces. There you go. At least it's moving in pieces. That's a benefit. And so we're going to go ahead and get positive 12x. And lastly, we'll get minus 20. So let's go ahead and identify. There's two x cubes up here. This one and this one. So x to the fourth is the lonely one up here. So that's going to be then minus 7x cubed. There's 3x squares, so 16 positive 14x squared. There's going to be two of these x's, so positive 2x minus 20. So then this will be the solution. This one will produce those solutions that we went ahead and for lab back out. All right, good. Let's go ahead and now work on 13. I'll give you the practice to kind of see it all over again. And what's important about 13 that I love about it is at least it gives you a slightly different method, well, to recognize, especially the shortcut is not always used every time you see imaginary numbers. And let me share why. Let me get this stuff moved out of the way. Let me share with you why 13. Okay. So moving on to 13. All right, with 13, we're going to go ahead and now explore that this one, first of all, has 2 plus I as a missing 0, and then positive 3i. So when you write this down, it's going to look like this. It's going to look as, and I'll start up here because we may be running out of space. 2 minus I, x positive, well, not positive, it's still minus. In these cases, when you do conjugates, it's minus in there just because that's how you are able to achieve that they make zeros. And over here, this is going to be x plus 3i, x minus 3i, and we're going to go ahead and solve for this. Now, we have two parts. This part, shortcut. Now, even though this one has i's, this part you're just going to FOIL regular method. Okay, so let's do the shortcut on this side. X squared minus 2ax plus a squared plus b squared. This one I discovered that from here that a is 2, b is 1. So we have the power to substitute that in. And we discovered that this is x squared minus 4x, and this is 4 plus 1, so it's just 5. So this polynomial will form those two imaginary numbers. Now on this side, the easiest thing to do is just FOIL. So, over here, let me see if I could, I'll use a different color because I don't want you to mesh it. X squared minus 3xi positive 3xi, and then the last one ends up being negative 9i squared. So what we get from here on this part, x squared, these middle terms, they cancel out. That comes out being negative 9i squared. But the last part of it, now we're going to switch back to black, is that the I squared is really negative. So like, just to give you an idea, this is really negative 1. So that means that becomes positive. Just like that. So when we solve for this one, we're going to go ahead and produce something similar to what we did before. But this time, what I'm going to do, just to make it easier, I'm going to move this. Move that parentheses as well. Over here to the front. I'm going to leave that where it's at. And what I'm going to plan to do to solve is just FOIL. So x to the fourth minus 4x cubed positive 5x squared positive 9x squared minus 36x positive 45. one of the things we're going to have from here is that the last simplification for solving this is going to be x to the fourth minus 4x cubed plus 14x squared minus 36x plus 45. So there's my solution to that one. All right, let's move forward then to numbers 14 and 15. All right, now when you're dealing with finding all zeros and they start talking about their to list complex solutions, automatically we're going to now encounter something new that we are going to be experiencing, that we are going to have solutions that are real and complex. And the possibilities is that we might have 4 and 0, 2 and 2, and 0 and 4. Those are the three possibilities we may have. And the only way you really find out is by graphing. So let's go ahead and graph it and see how many solutions we come up with. So the first one is going to be x to the fourth. Bring this out. This is good. I want it to be a little clicker. Oh, what I do want to do is erase this. So let me do that as we're... There. I'm going to go back to this, and now let's go ahead and see how this looks graphed. So this graph is going to be x to the fourth plus 2x squared minus 8. And there is... Well, actually, there's going to be some real solutions to this one. There's 2 of them. Now, there should be a total of 4, but in this case, there's 2. Now, the interesting thing is that what the solutions to the 2 are, and they're both fractions. Now, the way you discover to know what is it, this is when we go back to this, and we go ahead and discover p's and q's. So remember, this one has 1 as the q, this is a p. So negative 8 has the solutions of 1 and 8 and 2 and 4. 1, this is p. Remember, 1 is just 1 and 1. So really all my solutions for p divided by q, this is going to be all the p values, because remember, p is going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And my q values are going to be plus or minus 1. Oh, so it makes this even more interesting. Now let me go back to this, because one of the things that I want to make sure, that's it. So some of these solutions then, on this one, the real ones, I'm going to go ahead and we're going to have to, every once in a while, one of the things that ends up happening as well when you work with these is that you discover that you technically want, and let me kind of go back since I started this whole PQ method. This 1 and 1 is not the only factors. Every once in a while, this kind of goes off grid, kind of like what you see there. Because you could also get 1 by doing 1/2 and 2. That also produces 1. So, and there's more possibilities to it. So it actually really expands on some of the solutions that we may encounter. We normally don't get into that because it goes into a lot more. There's an infinite amount of almost possibilities of factors you could create once you actually get into this whole fractional business of it. So we just try to keep it simple at your age group. So let's go back and look at the graph and see if we can actually figure this one out. Because now what I would say the easiest thing to do is to set it equal. Let me see if those things even have factors already. Now this one has some real solutions, so we're going to have to do something here. I'm going to go ahead and first of all, I'm going to modify my graph a bit. And just rest assured, I'm doing this because I want you to have a solution, but you're not going to have anything this complicated on your test. It just will not, your test will not have this kind of features to it. Because finding these fractional forms, we might have something there here and there, but nothing this complex. I'm going to go by 0.1 on each one because I want to discover what it is. And so let me go back to this. Now we have to zoom in. We're going to go into 0.1s. Okay, and now we're going to move forward to see. Okay, so if you notice, this one's actually not even a 0.1. It's some kind of fractions above negative 1.4. And actually, it's an equal one here on the positive side. So that means it's going to be 1 point, let's see, if it's going to be 1.4. Let's think about negative 8. Let me go ahead and do the. All right, so after examining this, I'm going to announce in all my classes that we're going to actually change this just because we're getting into things that are not what the intention of this problem is. One of the things I would like for y'all to do is we're going to move this into a negative. And what that does, so really you want to write it all over it again. X fourth minus 2x minus 8 is that when we graph that, one of the things that it does is it gives us two neat solutions. It gives us negative 2 and positive 2. And what we're going to do with that is that we're going to go through the process of synthetically dividing that. So one of the things we discovered is this, that this one, when we have negative 2 and positive 2, we're going to have two solutions. So let's go ahead and synthetically divide it. And we're going to do it twice to this. This is 1. This is squared. 0, negative 2, 0, negative 8. And let's synthetically divide. So negative 2 times 1 is negative 2. Negative 2, negative 2 times negative 2 is positive 4. Negative 2, positive 4, positive 4. I did some kind of sign mistake here. Let's discover where. Let's see, negative 2, 0, negative 2, positive 4, right here. Negative, negative, positive 8. So 0. And then since we have positive 2 here, if I synthetically divide it here, and this is how you know that, because since when I was looking at it, I knew I had to do this, so that's why I went back and looked at my work. 1 times 2 is 0. 2 times 0 is 0. 2. 2 times 4 is 2 times 2 is 4. 0. All right. So then we discover that we have x squared plus 2. So we have these factors, x plus 2, x minus 2. Now, since this one has no b value, you go ahead and just directly set it equal to 0. So we do x squared plus 2 equal to 0. Subtract 2 to subtract 2. That cancels out, we get negative 2. And we take the radical of it, we'll discover the other two solutions are radical 2 plus or minus radical 2i. Now we can't take a radical of 2 because that's an irrational, so we leave it the way it is. That's more of a complete solution. Now let's move over to 15 and start solving this one. So when we solve 15, same thing. We have a polynomial that goes to the fourth. So one of the things we needed to discover is what the solution is to it by first examining how many are real and how many are complex. Because we also have the idea that real and complex is that we have 4, 0, 2, 2, 0, 4. So let's go ahead and write down our actual solutions. So let's see. We're going to get those solutions actually by graphing it, because that's what we're trying to do. We're going to determine which of these is going to or make that that kind of graph. So let's go back here. Make sure I'm writing there, and let's write down. In this case, we'll have 3. Oh, hold on. I don't want to raise the end. Ooh. I'm going to bring that down. 3 x to the fourth minus 4x cubed plus 4x squared minus 4x and then plus 1. All right, so there you go. Okay, now with this one of my solutions is going to be a possibility of a fraction. And it would make sense. If you look at the P's and Q's on this one, there's an actual solution that may be 1/3 here. So the only way you really determine if it could be 1/3, because it was showing that the solution's 1/3, and I think it was 1 or 2. Let me see what it was. It was 1. So it's saying the solutions were actually 1/3 and 1. So we take 1/3 and we synthetically divide it to see if it actually is a factor. If it synthetically divides, then we discover which one was right. -4, 4, -4, and 1. So then we get 1. Remember, this is my add and multiply. So when I add those, it comes out being -3. And then after that, we get -1, +3. We get a -1, we get -3rd, and then we get -1 here, and yeah, that was a factor. So this is going to be a solution, proved, because of that remainder 0. Now let's go ahead and synthetically divide by 1, and come up with a solution to that. So it'll be 3. 1 times 3 is 3. 0. 1 times 0 is 0. 3. 1 times 3 is 3, and another 0. So what we came up with, we proved that this x plus, not x plus, x minus, because that's how you discover what x minus 1/3, x minus 1, and 3x squared plus 3 are actual factors. Now, we have the benefit, just like the last problem, that this one has no b value. So to discover the zeros on that one, all we need to do is set it equal to 0. So we're going to subtract by 3, subtract by 3. We'll get 3x squared is equal to -3. Divide by 3, divide by 3. And we isolate our x squared to the value of -1. When I take the square root, we have x is equal to plus I, plus or minus I. So the 3 solutions to this, like if I was going to write down what the solutions are, if it says solutions or it says zeros or whatever it says on there, you're going to write down the solutions, which are going to be 1/3, 1, +I, -I. And those are my 4 solutions for this one. Okay, great. Let's go ahead and move forward to the last one, which is this one right here. It says use Schrady to be sure to identify domain and end behavior. So let's go ahead and start solving this. So to simplify for Schrady, it looks like the top is factorable. Let's see which factors will make -3. So it's going to be -4 and +1. So I can go ahead and I'll put this as x minus 4, x plus 1 as the numerator. And then at the bottom, it's going to be x minus 4, x plus 4. So we discovered that things cancel, which means we have a hole. We're going to make x minus 4 equal to 0. It's cancel one, you set equal to 0. +4 plus 4, we discovered that x is equal to 4. Afterwards, you got to go ahead and find what the solution is by putting it back into your simplified equation. This is my simplified equation. So we're going to figure out what f of 4 is by doing 4 plus 1, 4 plus 4. We'll discover the solution is 5/8. So we're going to be guaranteed a whole f4, 5/8. Now, as far as the roots, they just come from the actual numerator. So we're going to take x plus 1, set that equal to 0. So we're here going to have a root, be -1 at -1, 0. Vertical asymptotes, those are the ones that come from the denominator. So we're going to do x plus 4 equal to 0. So subtract 4, x is equal to -4. So that's what we have there. Now, as far as turns and tangents, what we have there, there is none in either one. None in the aspect of turns, because there's no multiplicity there, and none is in the aspect of togetherness. Now, as far as end behavior, this one's a balance equation. When I say balance, there's 3 options. And if you need to go back and kind of review that, this will be a good time to do so. those little 1 marks means they're equal, which we refer to as balance. So once you have that kind of, you take the leading coefficients and divide them, which in this case is 1 divided by 1. You write the horizontal asymptote as a function of y equal to that division of those leading coefficients, which is 1. All right, let's go ahead and discover what the y-intercept is. On this one, the y-intercept is going to be, that's probably the easiest thing to come up with. You put zeros on these, basically 0 plus 1 and 0 plus 4. I guarantee you have 0, 1/4. Now they're asking for the domain on this. Domain is pretty much everything except not the vertical asymptote. So if you're going to discover domain is going to be the set of x, element of all real numbers, such that x cannot equal, in this case, will be -4. It's the only thing it can't be. -4. And the other discontinuity, actually. In this case, can't be the whole either. X can't be that, and it cannot be the value of 4. Because we keep old domains and new ones. So let's go ahead and graph all this. So we'll start with the whole, which is going to be guaranteed to be at 4 5/8. So 4 5/8 is about there. And then we have a root at -1. And then we have a vertical asymptote at x equal to 4, -4. Horizontal asymptote at y equal to 1. Let's see, we also have a y-intercept at 0, 1/4. So it's going to be roughly right here. Okay, so because of that, I can now determine that the asymptote is going to run this way, cross that, be open at the hole, but run this way. Now, since this one is not together, that means it's guaranteed that the other one line is going to run this way. At that asymptote, they're going to be separate. So that'll be the solution for that part there. All right, so let's go ahead and find out what happens with these as we approach with end behavior. What happens when we go -infinity? The y values, they approach +1. When we go to +infinity the other direction, they also approach 1. Now they want to determine what's going -4 from the negative side. Okay, this is important to know that this is the negative side here. So that's negative, and I'm looking at the y values. Those are actually shooting off to +infinity. And when I go back over here and I look at it from the positive side, and the reason why this is a positive side is because all the values on the right are positive as you go in the number line from the vertical asymptote. On the positive side, we discovered that the y values are going down, so these are actually going to -infinity. So we're going to put -infinity here as far as one of the solutions. All right, good. Now let's go ahead and do the operations of functions. And they want us to add these functions, subtract them, multiply, and divide them. I'm going to do one of each because I'm kind of running out of time. And let me go ahead and just share with you, if you do x plus 1 plus x minus 1, 3x plus 3, we got to get a common denominator. So I got to put 3x plus 3 on this side. And on this side, we're going to do x plus 1, x plus 1. So one of the benefits that we get from here is that we get a common denominator. So I could put this all underneath one denominator. 3x plus 3. X plus 1. In the numerator, we're going to, so on this side, when I follow this part, I have 3x squared, positive 3x. And then over here, I'm going to have positive x squared, like when I follow these out. Positive x minus x minus 1. Okay, now the last step on this, let's go ahead and just discover what we have. Like we have 2x squareds that I have in common, so in this case we're going to get a solution 4x squared. I have a couple of x's here. These x's cancel, so we're left with 3x minus 1. So that will be my solution here with adding. Now subtracting is very similar, and so is when you multiply, you're just going to multiply across. So that means like subtracting is very similar to these steps. When you multiply, they're basically doing this. So like the solution then this one would be x squared minus x, or x plus 1, 3x plus 3. That'll be the solution of this one. Now the only thing that's important to note, and this is for the multiply, the f times u. Probably the only thing you need to know that's probably more important about than the multiplying and is when you're dividing them. So let me write down. You do need to get the reciprocal of it. So let me share that with you. We have x plus 1 divided by x minus 1 through x plus 3. This comes out being like this, multiplied by 3x plus 3, x minus 1. Now this one, when we FOIL, comes out being 3x squared plus 3x. Now I know this is a difference of squares, so we're going to have x squared minus 1 as far as the solution. All right, great. Hope this helps you. And here.